All right, welcome back to the chemistry lesson. So in this video, we're going to talk about energetics. So the big picture about energetics is that it's one way of classifying reaction. And of course, the word energetic means talk about energy. So how we classify is based on energy given out, taken in. We need to understand when we say exo, endo, what are the common things that we need to talk about. All right. And when we talk about energy, it's also important. We can also use this opportunity, right, to relate to life because we can't really change time. All of us only got 24 hours, but how can we manage our energy? What are the energy that we engage in that give us energy, okay, energize us, or what are the activities that really drain our energy so then we can manage and then balance ourselves. So that's something you can relate to life also. Right. So this there'll be two videos. Okay, the first part is for both combined and pure chem, and then the later part I will talk a little bit more for the pure chem side. Right. So energetic basically see the overall big picture. They are just opposite of one another. So you can just choose to memorize one of them. Right. See, endothermic, enter, endo, N means enter, X means exo, exit. Right? That means heat given out, heat taken. Enter means heat taken in. Right? Exo means heat given out. All right. So when you give out to and always remember, it's always we talk about temperature of the surrounding, right? Because there's no point talk about temperature of the molecules of the ions because we can't see them, we can't measure them. So every time we talk about temperature of the surrounding, and surrounding is a very big thing. I can say the temperature of the beaker, temperature of the solution, temperature of the stirrer. All right, all these are the surrounding. Just like right now you're learning, outside your house is a surrounding. Even you go out to a central, it's also a surrounding. Even you go to a school area, that is also part of the surrounding. Right? So it is surrounding is a very big word. Right? So definitely when heat taken in, then temperature will decrease. Right? Because you heat taken in from the surrounding, then surrounding temperature decrease. And likewise, heat given out the surrounding, then temperature increase. So instead of memorizing two, and then under exam stress, or sometimes during time factor not enough, you rush, you just couldn't recall exactly one, just memorize one of them, either endo or exto. Even some of the reactions, some of the common reaction, for example, if you memorize that decomposition, photosynthesis, endo, then those that not fall under these are most likely will be exothermic, right? So combustion, actually any reaction that involve oxygen, right, is mainly exothermic. Right? And of course, we also talk about physical process, right? Like the change in state. Okay, so this one, if you forget, very simple, just know that solid, liquid, gas. Okay, so what happens? What happens? No, okay, generally is that when you want to change one state to one state, right? You know that gas has the most energy, then solid got the least. So if you're moving from solid to liquid, less to more, of course, this is endothermic. You're taking in energy, but you're moving from more to less, like gas to liquid, gas to solid, liquid to solid, freezing, then of course you will give out heat energy. All right. And one thing about temperature also, do take note, temperature do come back after. I mean, when I say temperature increase, it's not increase forever one. All right. So this is the temperature graph. Take note. Okay. Anyway, nothing is forever. Right. When there's a reaction, temperature increase. But when the reaction finishes, you'll go back to normal room temperature. Right. This is exo. Sometimes you will see a V shape or inverted V shape. Okay, but it's the same idea. Increase when there's a reaction. When reaction finish, you go back to normal room temperature. And similarly, endo when it happens, it will decrease. Then when reaction finish, it will go back to normal room temperature. Right. So when we say increase and decrease here, it doesn't mean forever, right? Because we know a surrounding is a bigger place. At the end of the day, everything will go back to surrounding temperature. Right. So this is a very shortest topic for both combined and pure chem. Right. That's roughly what you need to know. Okay, especially for the combined chem. All right. Okay, then stay tuned to the second part for the pure chem students. You can stay tuned to the second part. When I talk about bond breaking, bond forming, how do we calculate? All right. See you in the next part if you are pure chem.